So in last problem we just find out the magnetic field which is working along the z direction. Okay, we can find it in another way. Let us say here we have not still, there is called pointing vector, right? Yes. Okay, we will discuss at last in this class. After that we will come again this problem. We can find out the direction of magnetic field just by using the pointing vector very easily actually. So pointing vector is nothing, pointing vector denoted by S, it is just 1 by mu naught E cross B. This is the definition of pointing vector. S is the pointing vector. So this is the pointing vector which essentially signify the direction of propagation, nothing else. E is electric field, B is magnetic field. So E, we know that E is along x direction. So unit vector will be I cap. B we have to find out. S we know that along x direction. So unit vector will be, this is along y direction. So it is j cap and it is the I cap. So it should be the k cap, right? Then we know that j cross k is I, right. So from here we can also find out that the magnetic field should work along the z direction. In the z direction we know that the unit vector is k cap. Okay, so let me discuss next problem which is also very interesting problem. The magnetic field in a plane electromagnetic wave is given By. By is given 2 into 10 to the power minus 7 into sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11 t Tesla. Tesla is the unit. Okay, this is our magnetic field. Then question is, first, what is the wavelength and frequency? This is the first question, and second question is what is the electric field, expression for electric field E. So it is very important question. So in first class we discussed and also we derived the form of electric field and magnetic field, right. What was those? That electric field is E naught e to the power minus I omega t minus kz. Okay, this was the form, but this form this is general form actually, and for B naught minus I omega t minus kz. Okay, this was these two form were there. Now these form are the general form. What does it mean? This is exponential, right. So we can also write it like this. First let us say this is our electromagnetic waves, any wave, not considering the electromagnetic wave, let us say this is any wave, propagating wave. For any propagating wave we can write that for that wave, the wave equation is psi equals to psi naught into e to the power minus I omega t kx or z. If it is the direction of propagation is z, then it is kz. Omega is angular frequency, t is time, k is wave vector. So it is correct, okay. But again it is the in general form why I am writing, we can write also, we know that we can write the electromagnetic waves like this, sine kz minus omega t, or we can write like psi 0 again in terms of cos kz minus omega t, or we can add phi as a phase difference, also the form of the propagating waves. Here it is a sine wave, if it may be a cos wave like this, if it is like this then it will be a cos wave, there is a phi. So, this is also related, if phi is pi by 2 then cos and sine can be interchangeable. So, we can write in both form, in this form, all forms are equivalent, but this form is actually more general form. We can derive the forms, these forms from this equation, as we know that to the power I theta equals to cos theta plus I sin theta, right. So, from here we can derive this form as well, but this form is most general form, but here to solve this problem or discuss further, we will in case of the radiation pressure or the energy density, we will discuss considering these forms. Okay. So, let me consider this sine form. Okay. Okay. So, if we consider the sine form, then we can write that what will be B? B will be B0 sine k, the direction of the propagation, we can say it is along the x direction. If we consider to kx minus omega t, we are considering the electromagnetic wave is propagating along the x direction, nothing else. Okay. So, and magnetic field along the by, k vector will be there, but we are not considering the vector sign here, we have just written by. So, it is just by. Okay. So, by is this. So, we can write this. Now, if we just compare, then we obtain that B naught is 2 into 10 to the power minus 7 Tesla. This is the B naught, and now x is there. So, k means 2 pi by lambda. So, it is 0.5 into 10 to the power 3. So, from here we can evaluate the lambda, and what is the unit? Here the unit is Tesla, so it will be just meter. Okay. So, now it is lambda equals to, if we just solve it, it will be 1.26 centimeter, and it is easy to find out the t. T is the time period. So, but we have to find out the frequency. Okay, we know the lambda, so easily C equals to nu lambda. So, from here also we can find out the nu as well, but also we can find out 1 by t equals to 1, t is the time period, it will be nu. So, it will be 1.5 into 10 to the power 11 by 2 pi. How we can write? If we compare here, so omega is this, right. So, omega is 1.5 into 10 to the power 11. So, it will be omega by 2 pi equals to 1 by t. We know these things, right. So, it will be second inverse. So, if we simplify this, then it will be 23.9 gigahertz. So, this is the frequency of the electromagnetic wave. Now, we know that B, this is the B. So, from B we can easily find out the E naught. E naught is B naught times C. So, 2 into 10 to the power minus 7 into 3 into 10 to the power 8. So, it will be 6 into 110 equals to 60. What will be the unit? Volt per meter. So, this is the E naught. Okay. The direction of propagation is x, magnetic field is working along the y direction. So, it is clear that electric field will work along the z direction, just like the previous problem. So, from here we can write that E will be actually Ez, it will be 60 volt per meter and sine 0. Okay. What was the form? B z will be also E naught into sine again kx minus omega t. So, this part will be same. right. So, we can write it 1.5 into 10 to the power 3 x plus 1.5 11 t, but the unit is volt per meter. So, this is the electric field. From here from magnetic field we can derive the electric field. Okay. So, this is very important problem. So, one more thing I have to discuss, I have to state actually, we know that some points like E, the magnitude equals to B by E C, or E naught equals to B naught by C, where C is the speed of the electromagnetic wave. It is essentially in free space, it is 3 into 10 to the power 8 meter per second. Now, let us say it is not the vacuum. In vacuum or free space it is correct, but if it is not the free space, if there is a medium, then what will be the changes. Okay. So, we know that C is equal to nu lambda. For any electromagnetic wave it is correct, C is equal to nu lambda, but it is for free space. So, in general we can write V is equal to nu lambda. This is the general form actually, where V is the velocity, nu is the frequency, and lambda is the wavelength. If it is free space, then only that velocity will be equals to the speed of the light, which is 3 into 10 to the power 8 meter per second. But in general it is V. That means if there is a medium, then the velocity will be changed. Okay, means let us say it is not a free space. If it is not a free space, if there is a electromagnetic wave, then the velocity will be V, not C. If it is free space, then only it will be C, otherwise it is V. So, C is changes to V. So, I am considering that there is a electromagnetic wave, it was travelling along the free space, but it entered, okay. Okay. Let us say this is a medium, this is a medium. So, electromagnetic wave was travelling, this is free space, this is also free space, but there is a medium, this it is not a free space. So, what happens? What will be what things are changed when it is entered in this medium, that we have to discuss. Let us say here the equation is C is equal to nu lambda, the velocity is C, frequency is nu, and the wavelength is lambda. Here it is also C is equal to nu lambda, but here the equation is V is equal to nu lambda. So, it is clear that velocity is changed when it enters in a medium rather than free space. Okay. So, C is equal to nu lambda, and we can write it V is equal to nu prime lambda prime. So, we can write it, but actually the frequency remains constant. Here also this is nu, here also this will be nu. In free space, in any medium, the frequency of electromagnetic radiation is constant, it will not change. Okay. So, nu will be fixed. So, lambda is changed, then only the velocity will be changed, right. So, actually lambda changes to lambda prime, as a consequences the velocity C changes to V when it enters in a medium from the free space. It is very important for any electromagnetic wave, we have to remind it. So, this okay. Let me discuss another problem, then we will discuss the energy density in the last part of this class. The fourth problem. Okay, let me find out a good problem here. It is very easy, it's just B naught. Okay, this problem. Rectangular parallel plate capacitor of dimension is given 5 centimeter into 4 centimeter is charging in such a way that the rate of change of electric field between two plates is given 5.65 into 10 to the power 11 volt per meter. Now, they ask to calculate the ID, means the displacement current. Okay. What is the displacement current? This is the definition of the displacement current as we know. Okay. So, phi E, phi is the energy electrical flux, which is EA. E is the electric field and A is the area. So, electric field is given, this is the electric field, area is also given. So, from here we can evaluate the electric flux. Okay. So, ID is like this. So, we can write it epsilon naught d dt of EA. So, area is constant anyway. So, dE dt. Okay. So, epsilon naught is the electrical permittivity of the free space epsilon naught, which is we know that 8.85 into 10 to the power minus 12. Area is given 5 into 4, that is 20. Okay, area is 20 centimeter square, but you have to convert in SI unit. So, it will be 002 meter square. So, 002, we are dealing all the parameters in SI unit, and the dE dt, the change of the electric field with respect to time, change of the electric field, which is 5 point, okay, it is as it is change. So, it will be volt meter inverse second inverse, as it is change of the electric field. So, it is just the multiplication and the value will be 0.01 ampere, means 10 milliampere. So, from here we can also calculate the ID. Okay. So, again let me discuss the last problem. Okay. So, this is the problem number 5, I guess, right? Yes. They have asked to calculate the intensity and okay, the RMS, root mean square, value of electric field of electromagnetic wave at a distance (10 meter) from a 100 watt okay electric bulb. What is given? Given is epsilon naught 8.85 into 10 to the power minus 12 inverse per meter inverse. Okay. So, we have to calculate the intensity. Okay, but this part we have not studied yet, right? We have not studied what is the value of what is the intensity and RMS value. Okay, so we'll do this problem after discussing what is the radiation pressure and the intensity of the electric field. So, to understand that, first we have to discuss the energy density. Okay, so we will discuss this part later. So, in this part I stopped here. In next part we will start the energy density. Thank you.